So 15 years ago when I started at Wistar, I was hired to run the microscopy facility. Several years ago we changed that from microscopy to imaging, mainly to represent the fact that we weren't just doing microscopy, we were doing a little bit of everything else. And most recently we've been getting into something very different. So just a real quick thing, this is a new piece of equipment that I just got an NIH grant for. These things are not cheap. It's the only way to really afford them. But this is another form when people talk about imaging. Okay, well, is it photography? Is it X-rays? It is, any other type of a thing? Well, this is a preclinical, here we go, preclinical small animal whole body imaging system. It looks a little bit like Robbie the robot. It's placed in our animal facility behind the barrier, and it's used for longitudinal studies mainly on mice, but you can also fit rats into it. The idea behind this is that you can follow disease progression in tumors that are labeled with either a bioluminescent or fluorescent marker. And you can take that all in one mouse over time. So you take the animals that we're looking at actually live in the same room as this. You take it out, you image it, you put it back. It's all very quantitative. It's all calibrated, and it's huge. So to give you an idea, that's Aubrey on the left, our newest employee, and Fred on the right, who's been with me for quite a few years now. But those three massive crates combined are what put the machine together. This is Bill, our technician, the PerkinElmer makes this unit, and he's the one who was putting it together for us. The thing that's different about this one, let me go forward to the next one. These are images that we took with the machine that we had up till now. Again, the idea is you're looking for a quantitative value from bioluminescence or fluorescence, which means if you take a 2D, in this case, image of something, looking down from the top, the heat map that you're seeing on there is an indication of basically how many cells are in that area. So you're actually doing photon counting with this thing. And you set it up. Again, you want to be able to do an experiment on the East Coast and get the same example or the same results that you would get on the West Coast. The big problem with the machine that we had up till now was that it was only 2D. If you tried to do anything in 3D, you couldn't. Or if you did, it was qualitative at best because you couldn't actually make those three-dimensional measurements. With the new machine, it's actually quantitative in 3D. So we can now, in addition to the bioluminescence and the fluorescence markers, we can also capture a CT. So we're getting into X-rays now as part of our imaging facility. So imaging is definitely a useful term, not just microscopy anymore. It's an interesting technique. I don't know a heck of a lot about it yet because we're just getting started. In fact, it saw first light last week. As you can see here, the combination of the fluorescent or bioluminescent marker from the top or from the side gives you that idea of exactly where it is in the body, but more importantly, how big it is. Especially if you've got a small tumor that's near the top, it's going to look brighter than a large tumor that's deeper down. And with the new system, you can calibrate for that. So this was actually the first image that we got with the CT element of the machine. And again, this is just kind of blowing me away that we now have to deal with radiation safety, and it has to be registered with the state and the city because it has a X-ray element inside. But yeah, a little bit of everything. I just wanted to show this because we just got this thing. I'm proud it took me a little over 2 years to get the grant for that. But that's what we deal with these days, so if I break it, I run into trouble. Anyway, but thank you. That's all I wanted to talk about.